Hello, this is Domenico with part 2 of using an aggregate supply of labor and aggregate demand for labor model. In part 1, we were first delving into the y-axis and the measurement of the average real wage rate, and understanding the difference between real wages and nominal wages through the use of these three formulas as a means to calculate real income or real wages. Real income illustrates the purchasing power of income when we take into account the inflation rate. So we saw with the United States, this data collected by the Federal Reserve, and it's tracking over time real income. And we focused on the year 2021, where we saw real income at $70,784. Real median household incomes in the United States at $70,784. That's taking into account the inflation rate. And we assumed in the year 2021 that the inflation rate on average is about 7%. Perhaps it's overestimated, but we used that value of 7% inflation to calculate this. So with the first formula, real income equals nominal wages minus nominal wages times inflation rate, we assume that the nominal wage was 76,000 approximately minus 76,000 times the rate of inflation, and that gives us a real income value of 70,784. The second formula, we're looking at nominal wage of 75,738 divided by 1 plus the inflation rate, gives us a value of 70,784. And the third formula, 1 minus the inflation rate multiplied by nominal wages. Again, if it's 7% inflation, 1 minus that decimal value of 7% inflation, 0.93 times 76,000, again gives us a real income value of 70,784. So that's the real income for a year's work on average in the macro economy. Unemployment in the United States over time from 1950 onward, we can see that's more or less hovering between 4 and 6%, right? Generally speaking, the business cycle is illustrating a long-run average level of unemployment between 4 and 6. So we're going to use 5% as our natural rate of unemployment. Here we can see the impact of the 2008 crisis, dramatically increasing unemployment to about 10%, the COVID pandemic driving it above 14 to 15%, and then it coming back down. So how do we draw this? Y-axis, we're measuring the average real wage rate. On the x-axis, the quantity of labor. We want to remember that the unemployment rate is calculated as the number of unemployed divided by the labor force. And you should keep in mind that the labor force is composed of the number of unemployed plus all of those who are employed. So those who have a job plus those who are actively looking for a job and not able to find a job, the sum of the two becomes our labor force. Unemployed divided by labor force multiplied by 100 gives us the unemployment rate. Okay. So first we're going to illustrate the aggregate supply of labor in the macroeconomy. So it's going to be this upward sloping supply curve. We'll label this ASL, aggregate supply of labor supplied by the household that owns labor as a factor of production. Then we'll have a downward sloping aggregate demand for labor, demand driven by firms demanding labor to produce some type of good or service. Actually, I'll make that a little bit more horizontal. You'll see why. Okay. So here we have ADL, aggregate demand for labor. Then it establishes an equilibrium. Here, point A. An equilibrium real wage, I'll just label that wage at the equilibrium level. And then we have the quantity of labor supplied and demanded. I'll just call that QE. All right, there we go. Now, let's also illustrate the labor force. So the labor force is the sum of all of those that are employed. So the ASL is right here. ASL is the number of all of those that are employed. Plus, we're going to illustrate those who are unemployed but actively looking for a job. And that will be our labor force. So our labor force, I'll put right over here. LF for labor force. I'm going to take that equilibrium wage and draw it horizontally all the way across until it equals our labor force. And here we have a quantity. And I'll call that the quantity of our labor force. Fine. Here's point B. So essentially, the distance between A and B, or quantity QE and QLF, is the value of our natural rate of unemployment. So to emphasize that, see here. All right, we have the distance between A and B. Again, the distance between QE and QLF illustrates the natural rate of unemployment that exists in this particular economy in the United States. So that is the value of that natural rate of unemployment. Okay? And in the United States, right, in the US, the natural rate of unemployment is about 5%. About 5%. So 5% of the labor force between QE and QLF is actively looking for a job but unable to find a job. And we know that the natural rate of unemployment, as we see here, is composed of three things. The natural rate of unemployment is composed of, number one, structural unemployment, number two, frictional unemployment, number three, seasonal unemployment. So the distance between ASL and LF is composed of these three factors. So you can imagine, let's illustrate this. All right, and we'll say this is ASL1, and this is ASL1 plus the structural unemployment. So the distance between ASL1 and ASL2, perhaps just to clarify this, this is getting a little bit messy, but just want to make clear what that is. So let's say this is ASL2, which is equal to ASL1 plus the structural unemployment. So that distance between ASL1 and ASL2 is the value of the structural unemployment in the economy. Then we also have this distance here. All right, and this could be the value of, we'll call this ASL3. This is equal to ASL2 plus the frictional unemployment. So I'll call it F. Whoop, that's not a good abbreviation, but anyway. All right, so there we have the sum of our employed labor force plus our structurally unemployed labor force plus our friction unemployed labor force. And then finally, we can illustrate the seasonally unemployed over here. So we'll call that, oops, actually we don't need that line. And so the distance between here and here, the labor force is going to be equal to ASL3 plus the seasonally unemployed. Okay, very messy, but just to get the overall concept. So the labor force is composed of all of those that are seasonal unemployed between this distance, all of those that are frictional unemployed, the distance here, all of those that are structural unemployment, the distance here, plus all of those that are employed. And that becomes our total labor force. So if we're able to alter the quantity of structural unemployment, frictional unemployment, or seasonal unemployment, that would increase or decrease the natural rate of unemployment. Okay, so that's it. That's what I want to discuss in this video. In the third video, it will just be an analysis. We're going to get rid of this brown line, this lighter brown line. We'll get rid of that and just quickly analyze this model for a paper exam. If you have any questions, feel free to comment those questions below, and don't forget to subscribe and to like. Thank you so much.